Hello everyone, video 2 of module 7. In this video I will show you how to finalize your sections for reinforcement design, also how to set the design parameters for steel and concrete design, how to choose the standards. Then we run the model and we do some basic checks about the displacements, about the drift of the structure, and also about the soil bearing capacity, and ensure the size of elements are correct, so we don't need to resize the piles or add more piles or also resize the foundation. Then after completing all of those basic requirements and ensure the model is completely ready and the interactions of elements are correct, we will go through the design of the steel and concrete elements. So guys, you can update the design parameters after running the model, but you cannot update the section specifications after running the model. So I want to show you how to finalize your sections for design. So I'm coming to define sections and doing one by one. So I'm choosing this section. Here we have few options. One is set modifier that we discussed before. The other one is concrete reinforcement. For beams, you cannot choose the size of bars. All you can do is the cover and also the type of element and the grade of the rebar. So currently what we have for grade of rebar, we just defined 500. So we don't have the round bar with grade of 250. There are two generally grades of bar we have in Australia: deformed shape and undeformed shape. Undeformed shape is a kind of a round bar with 250 megapascal grade of steel. Deformed shapes are deformed bar with 500 megapascal. So I'll keep it here. Here mentioned concrete cover to longitudinal rebar center. That means you consider the clear cover plus the stirrup or shear tie and half of a diameter. How much it can be? Say 30 millimeter, 35 millimeter cover plus 10 or 12 millimeter diameter of the reinforcement for shear, so that's 47. And we assume, for example, if we use 20 millimeter diameter, so 10, that would be 57. So currently the unit is meter, so we come here 0.057, 0.057. And here is mentioned reinforcement override for ductile beams. Sometimes you need to add more reinforcement for ductility for earthquake design, depends on the ductility ratio or ductility level you expect for the structure. We ignore this one and we just let the program do the design. So I press OK and OK. We do the same very quickly for this. So we're coming here, rebar correct, so that would be 0.57 as we calculated. Nothing else needs to be touched. Okay, now we see what we need to do for column. First of all, I'm coming here, just change this units to Newton and millimeter to make it easier to check what parameters need to be changed. So I'm coming here, column 400 by 400, 40 MPa. So this column, I'm coming to concrete reinforcement, and here we choose column, which is correct. The column is rectangular and I'm choosing tie. So the clear cover, say 35 millimeter. So we need to figure out how many bars we need to put in the column. Roughly, if you want to be very economic, we need to go for 1 person. So this column is 400 by 400. If we calculate 1 person of this area, would be 1600 square millimeter. So how many bars we have? We have 8 bars. So if we choose here N16, 8 and 16 gives you exactly the same number. So this is exactly 1 person. And then the ties, N is a deformed shape bar in Australia. There are some other size of bars based on different standards for American standards and European standards. So you can check which one is suitable for you and choose that one. I'm going for deformed shape bar, and then 300 millimeter is a reasonable space between the ties, not in the critical zones on top and bottom, but in generally 300 is okay. Currently, all I'm doing is calculating the shear capacity of the column. I just want to ensure that this space with this arrangement of bar is sufficient to support the shear load. Then for confinement and ductility requirement, if I need to add more rebar, I will. So the whole purpose of preparing this arrangement is just checking the shear capacity. So what those numbers mean? When it's mentioned number of confinement bars in 3 directions, that means the confinement bars along 3 directions. I need to see how many bars I need in this direction and also along 2 directions. It back to the space between the reinforcement. If the space between the reinforcement based on Australian standard is more than 150 millimeters, we need to confine all reinforcement and have a shear tie for all of them. If the space is less than 150 millimeters, we can keep one of them untied and the other one tied. So currently we have 400 by 400, say from center to the edge something around 50 millimeter. So center to center of these two are 150, which is very borderline. I prefer to keep it 3 each side. One thing I would like to tell you is sometimes the bar you want is not here. For example, you may after N40 or N25 based on your standard and it's not here. You can simply come here and add, and you can come here and mention, for example, we don't have it, I will go for M40. I can put M40 and then what is the bar area based on a square millimeter or whatever is the unit here, and also what is the bar diameter. I can put, for example, 40 millimeter here, and the area of 40 millimeter bar is 1256.6. so I put here 1256.64 square millimeter. Then I will press add, it's coming here, and then I press OK. And this time when I'm coming here, I can see N40 here. The same you can do for example, round bar or any type of reinforcement that you don't have. And also, I just want to show you the definition here. When we talk about the confinement bar along axis 3 is those bars. When we're talking about the reinforcement along 3 direction is the reinforcement here and here, not at these 2 edges, because it mentioned along 3 direction first. So just to show you what's happening, if I change this one to 4 and press OK, you see these 2 reinforcements are changing. So that is reinforcement along grid 3. So I will put it back to 3 and press OK and OK, and coming to the pile. So pile is a circular shape with 600 millimeter diameter. I'm coming here, so it's automatically selected. Okay, this is column, this is circular this time. I cannot change the shape because it's not rectangular. So it can be either tie or a spiral. So it's up to me which one I want to choose. Generally, spiral is more popular for piles, so I keep it here. Clear cover for confinement bars. Clear cover, so that's different. For columns, this is a clear cover. For beams, this is the distance from the edge to the center of the longitudinal bar. So you just need to be careful about the different parameters you need to input here, and you need to read them carefully. So cover for the piles generally should be more because they are connected to the soil directly. You may have casing, but the majority of times you may not have any casing if the rock is or soil is strong. So the mixture of concrete and soil here could be a little bit tricky. I personally wouldn't go for less than 75 millimeter, but you can check your standard and the construction methodology and piles. Concrete would be exposed to the soil and the moisture and any corrosive material around. Depends on if the soil or water is aggressive or not. So I take it 75. The area of pile is 282,000 square millimeter. 1% is 2800. If it's N24, that would be minimum 7. Guys, you need to consider the space between bars. It's not just a matter of the 1% ratio or less or more. It's a matter of having a practical arrangement. Shouldn't be very congested, shouldn't be very wide. So if we have 7 bars, because it's closing, actually we have 7 spaces. If I consider 75 millimeter cover, even to the center, not the clear cover, my intention here is confinement bar is the clear cover, but just let's assume just to the center, so it's 450 millimeter diameter of the part. So if I put here 450 diameter divided by 7, I have 200 millimeter space between bars, so it's a reasonable space. So I keep it 7 and 24. Again, N12 300 is reasonable. So reinforcement to be checked, not to be designed. This is my preference. You can go for to be designed, then SAP doesn't care what size of bar you choose. It checks the minimum reinforcement based on your standards. But you really need to ensure that all phrases of standards are being met by SAP 2000. Guys, you need to check the design procedure of SAP based on your standard by other local softwares or manually. SAP is a global software, perfect. I really like this, but because they are trying to accommodate and cover many regulations in this software, there are mistakes. You just need to ensure that everything is correct. Based on American standards, it's perfectly fine. It's been checked and it's been verified by the American Institute of Concrete and other contractors. You can use it. For other standards, Eurocode, Australian standards, Asian standards, different, you definitely need to check the procedure and ensure everything is okay. We go through this later on, but I will choose design to be checked. So I've done all those parameters. The other thing I need to set is my design standards. So I need to come here, and for each standard I need to set the design parameters. So I'm coming to steel design, view revise preferences. I want to check what standard I want to use here. So this is based on American standards. I will choose my local standards, which is Australian standards AS 4100. You see the factors change. Am I choosing those factors? Sometimes yes, sometimes no. The only thing generally I play is the demand capacity ratio limit. It's back to the range SAP wants to show you the color code. If it's more than 95%, SAP will show you red. That means the steel element is overstressed. It back to how confident you are. You may change it to 1. Sometimes even you may change it to 1.05. If you're really confident about the result, you may accept 5% overstress. It's really up to you. Sometimes you want to be conservative, you may change it to 0.8. I will leave it 0.95. Those are the factors that you can play with, but you must be very careful how you're going to play with that. So pattern live load factor 0.75, I will leave them as it is, but as I said, you can play with this. Currently those are fixed numbers, but if you click, you see if you can edit them or not. So this can be editable, this can be editable, those can be editable. Those are the capacity factors. Sometimes you want to change it, and you guys need to see exactly what you want to achieve from the design. So this is Australian standard for steel. I press OK. What else I need to check here is my combos. So I'm coming here and I'm choosing for strengths all ultimate combos. Just be careful, don't choose your envelope. So I'm coming here, comb U W and earthquake, yep, all. So I'm adding here, just double check, ensure everything is correct, no envelope is here, and then you can change this one to deflection, and for the deflection you can come and change your service earthquake. So comb S, wind, yep. Okay, so probably we chose some wrong combinations. Yes, when you choose, we chose ultimate by mistake. So I'm coming to S again and move back. I need to press Ctrl to add if I missed anything. Add. So let's see what we have. COM-BS, all earthquake, and then gravity and wind. COM-BU is wrong. I remove it. That means COM-BU EQX7 is not in the strings. Otherwise it wouldn't be allowed to come here. You can see it's not there. You always need to double check your jobs, guys. Again, we are human, we are not robot. We need to double check. And the good thing is when they are here, they are not here anymore. So even you can easily scan and see if there is any U here which is not selected. So there is no U here, just envelopes are here. And likewise for deflection, you can check either here or here, but it's way easier to check this side, because when you see S, you just simply figure out is missed. Otherwise you need to check the number of 1 to 8, for example, see if anything is missed or not. So automatically generate code base design load combination. I never use that personally, but it's up to you. If you trust the software, you can ask software to design. I explain you why. You may have different wind loads, you may have different earthquake load. SAP doesn't understand. SAP just add them one by one in load combination for wind. If you have 10 different load cases of wind, but you want to combine them, for example, you have a roof wind load, you have external wall wind load, which is leeward and windward and side, and you have internal pressure. You want to see all three in one combination. SAP doesn't understand that. SAP add them one by one for internal, one for external, one for roof. And that's how it creates the load combination. You can try it yourself just to save the time. I'm not going through this, but this is how it's happening. So I'm using this and I press OK. I do exactly the same for concrete. So I'm coming here in preferences. I'm choosing my own standard. Current is ACI 318. I'm coming to AS3600, which is for my standard, my local standard. 2018 is the latest one. I will keep this utilization factor again 95%. I'm not touching this. You can see which one you can change. You just simply come and click and see if it's editable or not, and I will press OK, and then again coming here, going to design combos and do exactly the same for strength and for deflection. So I'm coming here, COM-BU, W4, control click and add. So I have EQX to 8, EQY 1 to 8, G and W. Okay. Anything left here from COM-BU, I can scan it quickly, just S and W and envelope. So perfect. Coming to crack width. So here is checking the crack width. That means the service load. So we're coming here again and add them all, and I check here if there is any S remaining. No, all good. And again, automatically generate code. Better to untick it. If you don't, sometimes SAP again add it up when you delete it, but it's not impossible. You can delete it later in your combos, because these combinations will be added to your load combination that you created manually. So you can see suddenly SDL1 and other combinations coming for design. Okay, so we set everything up, ready to go for the design. Now we just need to run the model and see the result of the design. I will explain those results after run in our next video.